Let's now take a look at a couple of other examples. Suppose I'm given the function f at x equals 5e to the x, and I'd like to rewrite or evaluate the following. F at x plus 3. Well, all I really need to do is take my original function, 5e to the x, and add 3 to it. So I get 5e to the x plus 3. If I were graphing this, I would first graph 5e to the x, and then the plus 3 would say shift that whole graph up 3 units. So I would take the first graph, shift it up 3 units. F at x plus 2. Now notice the x plus 2 is in the parentheses. This is a left shift. If I were actually graphing, I would start with 5e to the x and move the whole graph left 2 units. In this case, what I just want to do is a substitution. I just want to rewrite the function. And so for the input, because that's where that x plus 2 appears, I'm going to remove the old x, and I'm now going to put in x plus 2, just as we have done several times in this course. And that gives me y equals 5 times e to the x plus 2. Now let's take a look at something slightly new. Suppose I had y equals f at x minus 1 plus 4. This has both things going on. It has a left shift of 1, or excuse me, a right shift of 1, get it right here, right shift of 1, and an up shift of 4. So if I were graphing this, I would take my e to the x, 5e to the x, move it right 1 and up 4, and that would make my whole new graph. So I pick the whole thing up and move it. If I were to write this actually out as in function notation, the plus 4 would get added on to the end, and the x minus 1 would become the new exponent. That would take the place of the old x. So I take out the old x and put in x minus 1. Let's take a look at one last example. Suppose I wanted to sketch the graph of f at x equals the absolute value of x, and g at x equals the absolute value of x plus 3 minus 5. Hopefully you remember the absolute value of x is the function that's shaped by a v. We talked about that way back at the first chapter or so of the book. So f at x is the absolute value of x, is the absolute value function. We graph it in the shape of a v with a turning point at the origin. So that's the blue graph. To get g of x, we have a couple of things going on. We have the x plus 3, which remember plus means left shift. So we're going to left shift 3 units. And we have minus 5, which is a downshift of 5. So notice if I just look at the vertex at the turning point on the absolute value has moved left 3 units and down 5. And you can notice on the red graph that the turning point is now at 3, negative 5. And now what we could do is just mimic the look of the graph, and we get the new V-shaped graph. These are exactly the same graph, even though the red one might look bigger. It's just because I've shown more of it. But it's the same graph, just shifted left 3 units and down 5. If we actually took a look, we could actually look at all the points and notice that in each case, the points on the blue graph all had their x values reduced by 3 and their y values reduced by 5. One last example. Suppose I have a table, f at x, and I'd like to graph g at x is f at x minus 1, and then subtract 4. So f at the quantity x minus 1, subtract 4. What we notice here is with that x minus 1 inside, we have a right shift of 1 unit, and we have a downshift of 4 units. So inside we have a right shift of 1 and then a downshift of 4. By the way, one of the points that I haven't made that I probably should, you'll notice I always do the left-right shifts before I do the up-down shifts, because I always do what's in the parentheses first, obeying the order of operations. So right shift first, downshift second. But now a right shift of 1 unit means I'm going to add 1 to the x's. So you'll notice that's what I did. So the point AB would become A plus 1, so there's the right shift. And then I have a downshift of 4, so the B becomes B minus 4. So notice to get the new values, all I'm going to do is go back to my old table, and I'm going to add 1 to all the x's, and I'm going to subtract 4 from all the y's. And that's exactly what I did to do this table. So notice I had the point 0, 7. So I add 1 to the x's, that gives me 1. And I subtract 4 from the 7, that gives me 3. Add 1 to the 1 gives me 2. Subtract 4 gives me 1. Add 1 gives me 3. Subtract 4 gives me negative 5. Add 1 gives me 4. Subtract 4 gives me negative 4. Add 1 to the 4. No, subtract, add 1 to the 4 because I'm shifting right. Gives me 5. Shift down 4 units. 3 minus 4 is negative 1. So if I can just figure out what happens to the generic point, then I just recreate that to make all of the values in the table. It's not that hard, but it does take some practice. You want to make sure you go out to the problems that are in the book and make sure that you can do these shifts by graph, by function, and by table.